Now, what are the topics we covered so far? We have seen the definition of graph, definition of null graph, trivial graph, parallel edges, multigraph, simple graph, sum degrees theorem, and then Havel-Akame result. So in this video, I'm going to discuss basic concepts of graphs, like what is the meaning of complete graph, what is the meaning of regular graph, and so on. Okay, let me start with the definition of complete graph. Complete graph. First, let me draw some examples. By using examples, I'll explain what is the exact meaning of complete graph. Okay. See, in a complete graph, between every pair of vertices, there exists an edge. In a complete graph, between every pair of vertices, there exists an edge. Okay. In most of the cases, we are discussing about only simple graphs. Okay, a simple graph is said to be complete graph if there exists an edge between every pair of vertices. For example, here I have two vertices. Like I have two vertices. One is A, another one is B. So between these two vertices, we have an edge. Therefore, it is a complete graph. Complete graph which is having two vertices, it is denoted by K2. 2 indicates number of vertices. Okay. Now look at second example. There are three vertices, like name them A, B, C. And between every pair of vertices, there is an edge. Therefore, it is called complete graph with three vertices. We can define it as K3. Similarly, in fourth example, we have four vertices. Four vertices. But is it complete graph? No, because between every pair of vertices, there does not exist an edge here. So, for example, if I ask from A to C, there is no edge. B to D, there is no edge. So, to make it complete graph, I had to draw two more extra edges. To make it complete graph, I had to draw two more extra edges like this. Now I can see the complete graph. Complete graph with four vertices, therefore we can define or we can denote it as K4. Okay. Similarly, fifth example, which is also not complete graph because there is no edge between every pair of vertices, right? To make it complete graph, I can draw one edge, I can draw another edge. Still, it is not a complete graph. To make it complete graph, I can draw one more edge, and also I can draw one more edge. Now it becomes complete graph with five vertices. So complete graph of five vertices. Right? In general, complete graph with n vertices denoted by Kn. Okay, a complete graph with n vertices denoted by Kn. Right? Then first important property you should remember, a simple graph is having maximum number of edges if it is a complete graph. Okay, right? A simple graph is having maximum number of edges only if it is a complete graph. Okay, remember that point. The second point is, suppose if you ask how many number of edges are in the complete graph now, the total number of edges, in complete graph with n vertices is equals to n into n minus 1 by 2. N into n minus 1 by 2. These are total number of edges in complete graph with n vertices. How we got this formula? Very simple. The proof is very simple. By using some degrees of vertices theorem, we can write summation I runs from 1 to n degree of all vertices must be equals to 2 times of number of edges in the graph. Number of edges in the graph. In this case, if I take complete graph with n vertices, each vertex having degree n minus 1. Verify this. For example, if I consider this example, K for example, please take K for example. What is the degree of A in K4? 3. So clearly, degree of A is equals to 3. And degree of B also 3. Degree of C also 3. Like degree of D is equals to 4. Correct? Means in, sorry for the mistake. Degree of 4, D is equals to 3. Degree of 3 equal to, degree of D is equal to 3. It means that in a complete graph of 4 vertices, every vertex having degree 3. Similarly, in a complete graph of 5 vertices, every vertex having degree 4. Okay, in a complete graph of n vertices, every vertex having degree n minus 1. Okay, every vertex having degree n minus 1. So therefore, first vertex degree is n minus 1. Second vertex degree also n minus 1. By continuing this process, last vertex degree also n minus 1. This is sum of all degrees of vertices. This is equals to right hand side number of edges in that complete graph. Number of edges in the complete graph. Okay, which is equals to how many times n minus 1 will be added? As many vertices are there in the graph. So clearly we have n vertices, therefore n times n into n minus 1. So n into n minus 1. N minus 1, n minus 1, n minus 1 added how many times? N times. Why it is n times? Because there are n vertices are there. So which is equals to 2 times of number of edges. Which implies that number of edges in the graph is equals to n into n minus 1 by 2. Therefore, in a complete graph, total number of edges equals to n into n minus 1 by 2 if there are n vertices. Okay, you have to remember this formula. It is a definition of complete graph. Okay. Here I want to introduce one more definition or one more point, that is called complement of a graph. Complement of a graph, because there is a relation between given graph and complement graph and complete graph. Therefore, I want to derive that relation. Okay. So what is the meaning of complement of a graph? Complement of a graph. I'll take simple example. By using that example, I'll explain what is the meaning of complement of a graph. Okay. So just assume that I have a graph with 4 vertices. I have a graph with 4 vertices. Name them as A, B, C, D. A, B, C, D. Assume that it is a given graph. It is a given graph. G of V comma A. How many vertices we have? 4 vertices. A, B, C, D. How many edges? 4 edges. Okay. For this graph, if you want to draw complement. If you want to draw the complement of the graph. So complement of a given graph is just a given graph with the same number of vertices. But if there exists an edge from U to V, then you have to change the direction of the edge in directed graph. Suppose if it is undirected graph, if there exists an edge from U to V in the given graph, that edge does not exist in the graph G bar. Okay, so very simple. Let me take G bar here. G bar also contains same number of vertices. Same number of vertices. We can say A, B, C, D like this. A, B, C, D. So from A, how many edges we have? From A to D we have edge, A to C we have edge. Therefore, we don't want to exhibit these edges in G bar. Okay. Now, what are the edges are missing from A? A to B is missing, right? Therefore, we can show that edge A to B, right? So similarly, means whatever edges are missing in G, those edges we have to exhibit in G bar. Whatever edges are there in G, those edges we have to hide those edges in G bar. Okay. Next, from B, there are two edges, B2D and B2C. You have to hide them. So B2C, B2D, hide, right? You can hide them. After from C, C to B, edge is there. C to A also edge is there. You can hide them. But C to D, there is no edge. We can draw that edge. C to D. C to D. Next, from D, so D to C, there is no edge. We have to draw that edge. D to A and D to B, we can hide those two edges. This is called G bar with 4 number of vertices, but this time number of edges are only 2 like this. Okay. It is called complement of a given graph. Right? In an undirected graph, G, in an undirected graph G, if there exists an edge from U to V, that edge does not present in G bar. That is a definition of complement of a graph. Okay. Now, if you could observe, if I join these two, what I will get, just if I combine these two, I'll get a graph. We'll get a graph with 4 vertices like A, B, C, D, 4 vertices. Right, I will get this graph, right? Okay. So if I combine these two, I'll get that graph. What is this graph? This graph is complete graph with 4 vertices. Okay. I can say it is K4, complete graph with 4 vertices. What did you notice from this? Means if I combine G and G bar, it will give complete graph. It will give complete graph. Now suppose if I ask how many number of edges are there in G? Number of edges in G. And then number of edges in G bar. Okay. How many number of edges are there in G? We have exactly 4 edges. How many number of edges in G bar? We have only 2 edges. This must be equals to number of edges in K4. Number of edges in K4. How many edges are there in K4 according to the previous formula? Please look at this formula. Number of edges in Kn. Number of edges in Kn. N in 10 minus 1 by 2, right? N in 10 minus 1 by 2. So number of edges in K4 means it is nothing but 4 into 4 minus 1 by 2. Okay. The left side we have 4 plus 2, which equals 6. Right side also we are having 6. Okay. So what I'm trying to say from this, number of edges in the given graph plus number of edges in the G bar must be equal to number of edges in the complete graph. Okay. This is the most important statement. Most important statement. In general, we can generalize it like this. Number of edges in the given graph plus number of edges in G bar. Must be equal to number of edges in Kn, where n is equals to number of vertices. N is equal to number of vertices. Okay. So this is the most important point you have to remember. I can say the first important point. Not one. Okay, first important point. Right? Is it clear? And the second important point is, second one is also most important point. Just observe this one. Suppose if I want to ask what is the degree sequence of G in this graph, what is the degree sequence of G in this graph? In the above examples, let me, before discussing this point, let me discuss one more point so that we'll get more clarity about this point. Suppose if I take any vertex, let V belongs to given graph G, then degree of V in G plus degree of V in G bar must be equals to number of vertices minus 1. number of vertices minus 1. We know why it is number of vertices minus 1. Obviously, if you take degree of V in G and degree of V in G bar, if I combine those two, definitely we'll get a complete graph, right? In a complete graph, what is the maximum degree of any vertex? The maximum degree of any vertex is V minus 1 only. Are you getting point or not? For example, look at this example. This example, it is a complete graph with 4 vertices. What is the maximum degree of any vertex here? So maximum degree of any vertex is only 3. 3, 3, 3. It is a complete graph with n vertices. Maximum degree is only n minus 1. So here I'm taking complete graph with v vertices. Therefore, maximum degree equal to v minus 1. Okay. This is also most important result if you have to remember that. Degree of v in G plus degree of v in G bar must be equal to v minus 1. Let me check it for previous one. What is the degree of A? Let me take example now. You'll get clear idea. Degree of A in G plus degree of A in G bar must be equal to total number of vertices minus 1. Total number of vertices, how many we have? 4 vertices. 4 minus 1. Let me check it. Is it correct or not? What is the degree of A in G? Obviously, degree of A in G, that is 2. Degree of A equal to 2. So degree of A means which is 2. Plus degree of A in G bar, which is equal to 1. Which equals to 4 minus 1 is 3. Exactly satisfied or not? Yes. Therefore, the second result is also most important result. Degree of V in G plus degree of V in G bar must be equal to number of vertices minus 1. This is the second important point. Now the third one is look at first example which we consider. If you take degree sequence of the graph G, degree sequence of the graph G. So degree of A is equals to 2, degree of B also 2, degree of C also 2, degree of D also 2. Is it correct or not? Or else I'll take one more graph, you will get, okay, no need to take one more graph, unnecessary time waste, okay? So degree sequence of the given graph G is 2, 2, 2, 2, all are 2 only, okay? Degree sequence of G is equals to 2, 2, 2, 2. Everybody is having degree sequence only 2 to 2 only. Okay, the degree sequence. And what is the degree sequence of G bar? Of G bar. Look at the degree sequence of G bar. A is having degree 1, B is also having degree 1, C also degree 1, D also having degree 1. Therefore, the degree sequence of G bar is equals to 1, 1, 1, 1 like this. Okay. Actually, why I'm discussing this point means, please remember this point. In the exam point of view, they will provide degree sequence of the given graph and they will ask what is the degree sequence of its complement. What is the degree sequence of its complement? In that case, you can use the formula is, suppose let cardinality of G or order of G is equals to suppose assume that there are n vertices in G. Let us assume that there are n vertices. There are n vertices in G. There are n vertices in G. If K1, K2, K3 up to so on Kn is a degree sequence of G. Okay. Suppose if it is a degree sequence of G, then I can find degree sequence of k1, k2, kn in G bar. I can find degree sequence of k1, k2, kn in G bar. Okay. Right. Then the degree sequence of G bar is equals to, how to get degree sequence of G bar? Total how many number of vertices are there? N vertices. If there are n vertices, each vertex having degree n minus 1 in the complete graph. Correct? Each vertex having degree n minus 1 in the complete graph. Therefore, from that n minus 1, we have to subtract k1. So n minus 1 minus k1 minus k1. It is very simple logic. I'll explain in detail. First, let me write that point. Another one is n minus 1 minus k2 and so on. N minus 1 minus kn. This is the degree sequence of G bar. Degree sequence of G bar. Let me take the previous example which we considered. Degree sequence of G is equals to, please go back to previous problem, or else we'll take another example. Instead of taking previous problem, we'll take another example. So assume that it is a given graph with 4 vertices and then 3 edges. Then what about G bar? G bar must contain same number of vertices. Okay. G bar must contain same number of vertices. But here, suppose if I give names of the vertices like A, B, C, D, so A to C there is an edge, A to C there is an edge. That edge should not present in G bar. Okay. But A to B there is no edge. We have to draw that edge in G bar. Similarly, A to D also there is no edge. We can draw edge from A to D. Right? That's all. With respect to B, there is no edge from B to A. That edge we have already drawn here. Okay. B to A edge already done. Next, with respect to D, D to B is okay. D to C is not there. We can draw it. D to C. Okay. D to C. This is called G bar. 4 vertices and number of edges are only 3 edges. Okay. Obviously, if I join these two, what we'll get? We'll get a complete graph with 4 vertices. Okay. We can get a complete graph of 4 vertices like A, B, C, and then D. This is a complete graph with 4 vertices. Correct? Now, what I'm going to ask, what is the degree sequence of the given graph G? Degree sequence of G is equals to. So clearly, A is having degree 1, and B is having degree 2, C is having degree 2, D is having degree 1. But degree sequence should be shown in the form of either increasing order, decreasing order. Let me take in the decreasing order. Okay. So if you take decreasing order, 2, 2, 1, 1. 2 to 1, 1. Okay. And what about number of vertices in the graph? Number of vertices in the graph, that is equals to only 4 vertices. 4 vertices. Now I want to find degree sequence of G bar. Degree sequence of G bar. How to find degree sequence of G bar means very simple logic. See, in a complete graph, for any vertex, what is the maximum degree? That is n minus 1. That is n minus 1. Maximum degree is n minus 1. Okay. So therefore, here if its degree is 2, means degree sequence of G is equals to 2, means here total number of vertices are 4. Total number of vertices are 4. Therefore, 4 minus 1, that is 3. Each vertex in complete graph must have maximum, must have 3, degrees 3. Therefore, we can say 3 minus 2. We can subtract 2 from 3. Similarly, 3 minus 2. We can subtract 2 from 3. Next, 3 minus 1. And then 3 minus 1. Do you know why it is 3? The 3 indicates that if the graph contains 4 vertices, then the complete graph must have maximum 3 edges only, right? Therefore, I'm taking 3 here. Okay. So 3 minus 2 means that equals to 1, 3 minus 2, 1, and 3 minus 1, 2, and 3 minus 1, 2. This is the degree sequence of G bar. Let me check is it valid or not. It is for degree for whom? So obviously it is degree for, I can say, pendant vertex B. This one is nothing but degree for C. Let it be, it is degree for A. So degree of D like this. Is it clear? So what did you notice from this? Just go back to this formula. If you know the degree sequence of G, then the degree sequence of G bar can be computed by using this formula. What is n minus 1? Here n is equals to 4. N is equals to 4. 4 minus 1 means 3. So from 3 minus k1. Who is k1 here? I can say it is k1, k2, k3, k4. Right? K4. So this is nothing but this part. 3 indicates that n minus 1. Minus, it is nothing but k1. Okay. Is it clear now? Similarly, it is n minus 1 minus k2. N minus 1 minus k2. So like that, we can find degree sequence of complement of a given graph. Right? The most important point we have to remember is degree of V in G and degree of V in G bar must be equal to total number of vertices minus 1. Okay. So here we had discussion regarding complete graph and the relationship between complete graph and complement of a graph. Right? After completion of complete graph definition, then we'll discuss another definition, which is cycle graph. Cycle graph. Generally, cycle graph can be defined only if the number of vertices are greater than or equal to 3. Because to form a cycle, compulsory minimum 3 vertices are required, right? Therefore, this definition is applicable only if number of vertices are greater than 3. Okay, greater than 3. The simple definition only. We don't want to waste time for cycle graph definition. Suppose if I have 3 vertices. It is a structure of the cycle graph with 3 vertices. We can define it as C3. So it is a structure of C4. Okay. It is C5. C5. So what is the meaning of cycle graph now? A cyclic graph of order n, a cycle graph of order n must contain a cycle of length n, must contain a cycle of length n, and degree of each vertex is exactly 2. The degree of each vertex is exactly 2. Okay. Now look at this one. C3, there is a cycle of length 3. C4, there is a cycle of length 4. C5, there is a cycle of length 5. Okay. The first point you have to remember in this properties of cycle graph is number of edges in cycle graph of order n must be equals to number of vertices in cycle graph of order n must be equals to length of the cycle. This is a basic property. Okay. Number of edges in cycle graph of length n and number of vertices of cycle graph of length n is equals to length of the cycle. So clearly, if you take number of edges in C3, there are three edges, three vertices, and length of the cycle also 3. Therefore, this property is perfectly valid. What is the degree of each vertex in cycle graph? Obviously, it is 2, right? Degree of each vertex in cycle graph is 2. Degree of V in Cn is equals to, means each vertex having degree 2. Each vertex having degree 2. Then how many number of edges are there in the cycle graph of length n? Obviously, how many number of edges are there? Number of edges, only n edges. Only n edges. Okay. You can also do by using sum degrees of vertices theorem. What is sum degrees of vertices theorem? The sum degrees of vertices theorem says that summation I runs from 1 to n, degree of all vertices must be equals to 2 times of number of edges. That is sum degrees of vertices theorem. But in cycle graph, degree of every vertex is 2 only, right? Just observe any cycle graph. Any cycle graph, degree of any vertex must be 2 only. Therefore, each vertex having degree 2, therefore 2 plus 2 plus 2 up to so on plus 2. This total must be equal to 2 times of number of edges. But how many times 2 will be added? Exactly n times. Okay. Therefore, n times will be added. Therefore, n times 2 will be added. Therefore, it becomes 2n is equals to 2 times of number of edges. Then 2 to get cancelled, we have number of edges in cycle graph exactly n. Right? So this is the way you can remember the number of edges in cycle graph. Is it clear? These are basic definitions. Next definition is wheel graph. To define wheel graph, number of vertices must be greater than or equal to 3. Then only wheel graph can be defined. Why n greater than or equal to 4? Means wheel graph is denoted by Wn. Okay? Wheel graph of n vertex is denoted by Wn. First, let me explain how to construct wheel graph of order 4. W4. Basically, W4 is derived from cycle graph of 3 vertices. Cycle graph of 3 vertices. Similarly, W5 can be derived from cycle graph of 4 vertices. Cycle graph of 4 vertices. In general, Wn can be derived from can be derived from Cn minus 1. See here, W5 constructed by using C4. W4 can be constructed by using C3. In general, Wn can be constructed from Cn minus 1. Instead of writing derived, we can say constructed. Wn can be constructed from from Cn minus 1. Cn minus 1. Wn can be constructed by using Cn minus 1. Observe how we are going to construct. Suppose if you want to construct W4, first we have to take C3. If you want to construct W5, we have to take C4. Let me construct W4 first. First take C3. It is a cycle graph. Cycle graph of 3 vertices. To construct W4, you have to take cycle graph of 3 vertices as it is. And in addition to that, we have to take one extra vertex. Which is adjacent to remaining all other vertices. Which is adjacent. Adjacent means common edge. Which is adjacent to remaining all other vertices. Suppose if I have three vertices like A, B, C. then definitely this newly added vertex must be adjacent to all these three vertices. Therefore, it is adjacent to B, adjacent to A, adjacent to C. This is called wheel graph. Okay, this is called wheel graph with four vertices. I can say this middle vertex is called D. D. Commonly, we can call it as hub. We can call it as hub. Okay. Let me take W5. W5 derived from C4. C4. First, let me see what is C4. C4. Let it be A, B, C, D. There are four vertices. Okay, there are four vertices C4. Now you want to construct W5. I can take C4 as it is. And take C4 as it is. Okay. Now we can take one vertex which is adjacent to remaining all other vertices. Let me take one vertex. It should be adjacent. Adjacent means there should exist some common edge between any two vertices. Okay. So this newly added vertex, if I call it a D, if I call it as E, then this E must be adjacent to D, adjacent to A, adjacent to C, adjacent to B like this. Okay. This is called wheel graph of order 5. Wheel graph of order 5. Is it clear? In general, Wn can be constructed by using Cn minus 1. Then how many total number of edges are there? Total number of edges. In Wn is equals to. Observe how we are going to construct now.